Hi there, this is Jacob Nash Engineering Lessons, and this is Unit 1.2, Lesson 2, and this is an Introduction to Electricity. So first, we have to figure out some things that electrical energy can and cannot do. So it can be converted, it can be stored, and also can be transmitted. So that's things that it can do or be. And then things that it can't do or be is it can't be created or destroyed. So that's some things that are important to consider. And you might think, well, how, like, it seems like that electrical energy would have to be created at some point, but it just always exists. It can just be converted and transformed into a new type that's more visible and usable for a certain purpose. And let's see, what else should there are different properties of an electrical energy, and the different properties that there are is there's a current, there is a voltage, and there's also resistance. And sorry that my handwriting's not that good. That's just because, like, this stylus is kind of off-centered. I've said that probably in a lot of the videos, but in case you didn't hear that before. And the current is the net transfer of an electrical charge per unit of time, and the voltage is the potential difference measured in volts, and the resistance is the opposition that a device or material offers to the flow of the direct current. And that's the definitions by PLCW, but it might make more sense later on what these three things mean. But there's different letters that can be used for these, and also different units. So for current, you can use an uppercase I, and let me just tell you something. If you think the uppercase I is like that, then you are wrong. I hate that, because it has to have that on it. Good. That's supposed to be a check mark. I hate it when people only do a line, and that's because it looks the same as a lowercase l. So that's something that really is annoying when websites, when you try to type and then it makes it like that. Like if you typed illustration, or even just the word ill, it would just look like that. It could be or la, but or like any combination of L's and I's. How do you know? The only thing you need to do is add that. Anyways, then voltage is V, and then resistance can be described with the letter R. And the units for current can be amps, which is described with the uppercase A, and then volts for V, so lowercase v, and then ohms, which is used by omega Greek letter. And ohms is spelled like that. And now we can actually talk about Ohm's law, which basically it's showing you the relationship between voltage, current, and resistance. And here are 3 equations that you can remember. V equals I times R. I equals V divided by R. And then R equals V divided by I. And an easier way to remember this, if that's hard to remember, is, that's terrible. By drawing just a simple triangle. V at the top, then I, then R. And add some signs. So you have a division sign, then multiplication sign. So whichever one you circle, whatever you're trying to find, so you can circle V if you're trying to find V, look at the other 2 and see what it is. So I times R, but if you're trying to find the current, then you can see that it's V divided by R. Or if you're trying to find the resistance, then you can see that it's V divided by I. If that's too confusing, just try to remember those equations. But that is Ohm's law, and that's important when you're solving problems. There is also another law called Kirchhoff's law, Current's law, and it's not something that I'm going to explain right now because it wouldn't really make that much sense since I haven't talked about the 2 types of currents, circuits, the series circuit and parallel circuit, which are in the next 2 videos, but I will go over that. And let me see. Yep, that is it for this video. So thank you for watching. Or actually, sorry, never mind. Sorry about that. There was one other thing. Okay, so here's how you can draw a circuit. This is the last thing that you should know. For a battery, you can do this. You have a long line, a short line, another long line, another short line. Then you have the positive side with the long line, and then the negative sign with the short line. And that is the battery. Then the wire is just a straight line. Here, let me actually do this. The wire is this. You can just draw it like that. And then the resistor is going to look like this. And you can draw it like that. And then that's still the wire. And then for showing a switch position, it would be on if the 2 pieces of wires are connected, but if it was off, it would look like that. It would be not connected. And then the battery source, which could be a light bulb, might look like this. So then we connect back. Yeah, do that. So that's not that good. Keep zooming out, but what's in dark blue is the wire. What's in light blue is the resistor. What's in supposed to be green is the battery source, and then the black is just the battery itself. And you'll learn that that would be considered a series circuit. So sorry that just a couple minutes ago I said that was it for the video, because there's actually another thing. There's different parts of a circuit, and let me say what they are. This will be the last thing though. So there's actually 5 to be total, or exact, I mean. And the first thing is a source. It needs to have a source. That might be the battery. it needs to have a conductor. And it also needs to have a load. That could be the end result. And it may or may not have a switch, but it could. It's not necessarily needed. And it also needs to have a path. Those are the 5 things that it could have. But that is that's it for this video. So thank you for watching, and be sure to see the next videos on this unit. Thank you.